Hey everybody, welcome back to the Engineered Angler. We're going to leave that thing alone for a while. I haven't had a chance to fish with it. I had to make a trip down to Miami, so as soon as I catch a fish with that, I'm going to make a short video and I'll make it look like it worked perfectly the first time. But if you know, you know, right? For this video, I want to go through the process of my first time getting into casting lead jigs. I don't have anything to melt lead, and I don't have heat-resistant silicone for the mold, and I don't even have a master for the jig head or the jig hooks or really anything to do this. So the first thing we need to do is to get online and do a little shopping. So the first thing I want to look at is these lead melting pots. I want something small, and I want something that's easy to store when I'm not using it. And I want something that doesn't hold a lot of lead. And I don't want something that's very expensive. This American-made one has really good ratings, but it's almost 80 bucks, and it looks so similar to the really cheap Chinese ones. Kind of makes me think. So I'm looking for something around 50 or 60 bucks. The one on the right is looking pretty good to me, even though the ratings are kind of mixed. And I'm sure a lot of you out there saying, why don't you get one of the Lee melting pots? A lot of people use them. It's easy to dispense the lead out of the bottom with a little lever. But I really don't want anything that big sitting on my counter. The one on the right here is only 37 bucks. It has decent ratings, but they look like phony reviews, even though that thumbs up in the picture kind of almost sold me. So I decided on this middle-of-the-road melting pot. I've got the Mold Max 60 heat-resistant silicone, about a pound of lead, the 90-degree 5/0 hooks. These are round bed hooks, and the 10mm assortment of 3D eyes. So our total ends up being right at $123.53. Not too bad. Oh, and one more thing. The folks at Resoners reached out to me. They saw my videos and they noticed that I didn't have a vacuum chamber to get the bubbles out of my silicone. So they offered up their Airless Pro. And this thing looks pretty nice. It's got a built-in vacuum pump right in the top of it. This way you don't have to store a separate vacuum pump. And apparently the pump can bring this thing down to minus 99 kilopascals. That's a pretty good vacuum. I like that the readout and the controls are right on the top, so it's easy to see and easy to stop it if you need to. And the container has a pretty good volume. I'm looking forward to trying this. Hopefully it works as good as it looks. So on my last fishing trip, I really ended up having to rely on soft plastic on a jig head because the fish really were hanging close to the bottom in grass or really close to oysters. So most of the fish I caught, trout and even a small cobia, I caught on a soft plastic mounted on a jig head. And I've been using sort of generic, inexpensive jig heads from, well, whatever tackle store was closest at the time. But I really like jig heads that are perfectly round and have a giant eye in the middle. And I've got to decide whether I want a 90-degree hook with a tie and eye goes 90 degrees to the shank, or the other option is a 60-degree hook where it comes off on a bit of an angle. Because of the shape of this head, I think the 90-degree is going to work better. I want there to be a barb on the shank here as part of the casting. And I'm just going to have a basic jig hook with probably either an O'Shaughnessy bend or just a round bend. So I want to be able to put in a 3/8 eye on there and have maybe a 1/16 of an inch of a rim around it, maybe slightly less. And I want the full diameter of this thing to be as small as I can have it and still be able to fit that eye. So probably something like 7/16. So I'm probably going to end up with a 9 or 10mm eye. And then the diameter of this is going to be something I'm going to have to work out. I hope that I can do the master with a dowel, but we might have to use clay. We'll see. But the key here is being able to adjust the amount of weight without changing the shape of the head. And if this is the diameter, that stays the same. Then to change the amount of volume so we can change the weight of the head. Since this is just a cylinder, we can just change the thickness of the cylinder itself. So the fatter, the heavier, the thinner, the lighter. So if this is your first time to the channel, my name is Franco. I'm a professional engineer, a lure designer and lure maker, and an avid fisherman. And I make these videos to try to share some of the tips and tricks that I've learned along the way and to add a little bit of physics and engineering to the art of lure making. And while we're waiting for our shipments to come in, let's do a little work on the math and creating that blank. So I've got some 1/2-inch dowel and I just want to make sure it's cut square. And I'll cut maybe a 2-inch piece. Now we got to make sure we get the eye centered on this thing. Let's drill a pilot hole in this scrap piece of wood. Now I'll drill a 1/2-inch hole part of the way through. Now with my dowel in the vise and using the 1/2-inch hole we drilled as an alignment socket, just put it over the dowel, align this bit, which is our original pilot hole bit. And with that next pilot hole, we should end up with a perfectly centered hole in the dowel. All right, so we've got our little dowel with the little center guide hole, and that's there to guide the centering of the eye socket. But the next real decision we have to make is how deep this has got to be. So we can work the math a couple of ways. We know that we've got 11.35 grams per cubic centimeter for the lead, and I know what the diameter of the dowel is. So I can just sort of figure out how many millimeters of depth per gram of lead, and then I can just find the depth for 15 grams and 7 grams. So I think that's what I'm going to do. All right, so here's the actual calculation for the thickness of this cylinder. So using the diameter of the dowel, which is 12.44 millimeters, I calculate the area of the face of that, and it's 1.22 square centimeters. So since I want to make a 1/4 ounce, which is right around 7 grams, and I know that 1 cubic centimeter is 11.35 grams of lead, I know I need 0.62 cubic centimeters of lead. So that means that the volume of this thing has to be 0.62 cubic centimeters. So knowing the area, I just need to calculate for this thickness, which I'm calling T. So I just divide the volume I'm trying to get, 0.62 cubic centimeters, by the end area of the cylinder, 1.22. And that gives me 0.5 centimeters, or thereabouts. And I did the same thing for the 1/2 ounce, which is 15 grams, more or less. So I need a little more than a cubic centimeter, which is 1.32 cubic centimeters of lead. And then of course, again, to find the thickness, I just divide my area into my volume, and I get 1.08 centimeters, which is probably going to be right at 1 centimeters thick. So we'll end up with a jig head that's a 1/2 centimeter thick and a jig head that's a full centimeter thick. All right, my plan is to cut the 2 sections right here on the lathe. This way I can get a nice square cut, and I'll just use a saw blade for that. But I want to go ahead and mark on this painter's tape where I'm going to cut. And before I actually cut, I want to make sure that that hole is drilled through as far as I can, so I have the center of the dowel all the way through both cuts. All right, I think that'll do it. And get a good solid mark for my cut. And then it's just a matter of putting this hacksaw blade on here in the precise spot. And there you go. It's a pretty clean cut, and we do have our guide hole on the other side. I'll go ahead and cut that other one, and we'll be ready to go. All right, since I had the dowel there already, I went ahead and cut a 3rd dowel section that should produce us about 3/8 of an ounce, which should be somewhere between 10 and 11. I'm going to put 10 grams, and ironically, that's probably going to be the one I end up using the most. All right, so the next step is to drill some eye sockets in here so that those big eyes will be centered. And the trick is going to be to do it without marring this or chipping out the edges. So what I'm going to do first is I'm going to put a little bit of super glue around the edge, and I'm going to use paper towel to make sure I don't get a big lump on it. And I'll squirt it with a little accelerator. And I place the dowel underneath it to keep it from heading south on me inadvertently. Just want to break those outer edges, and then we'll switch to forward running. Yeah, that super glue really hardens the surface. Seems to do the trick. And I'll get back to you guys once I got all, I guess, 6 eye sockets drilled in. All right, I know it's only been 10 minutes since we ordered all this stuff, but it all came in through the magic of YouTube. Ouch. That's lead. And we even got this thing. I'm surprised they got this to me so quickly. This is the vacuum chamber. Really excited to try this thing out. But before we actually open all that stuff up, it occurred to me that some of you out there maybe don't know what I'm up to actually making this stuff out of wood when you're expecting to see a lead jig head. Well, what I'm doing by making these is essentially making a mock-up. This is going to be a blank or a master, essentially a scale model of what it is you want to mold. So I'll use this along with the hook that I use with it to create a mold that then will be used to cast the lead. And in the end, what we'll have is a little lead cylinder just like this with a hook in it. So hopefully that clears up any confusion anybody out there might have had. And here's our lead bar and our jig hooks. Looking pretty good. Our 10mm eyes. Oh, that's for another project. All right, our smooth on mold making silicone. This is the Mold Max 60, which is their high heat silicone. And finally, the melting pot for the lead. And this is the one I got. I'm not going to know whether this is a good one or a bad one or intermediate until I actually used it. At least it was well packaged. And it looks pretty nice. All right, so that's what it's going to look like, kind of put together. That's the 90-degree 5/0 hook. And you can see I've drawn a circle there the size of the eye or the size of the jig head. And the next thing I need to do is assemble the head with the hook. All right, so using the calipers, I'm going to go ahead and mark the center of the width. And I'll just pick any old spot and mark myself a spot right there. And that's going to be one of the points where the hook comes out of. And I'll make sure it's marked with a pen so I don't lose it. Then I just need to go 90 degrees off of that point. And I'm going to mark this circle so that I can then mark the jig head where the 90 degree is. And mark it, make sure it's right in the center. Now I have to cut the hook so I can assemble the two parts into the jig head so I can make the assembly. First the tie and eye, and I'll cut off the bend in the hook so I can just slip this end into a hole I'm going to drill. Then I can just sort of insert the hook, and I'll take another hook and set this on top of it to make sure I've got it about right. So I've got it inserted just a little too far. That looks just about right. And I've got to do the same thing for the other two heads. So with this mounted in this little vise, I'm going to put a tiny little drop of crazy glue on there, barely visible, just enough to hold it in place. And I'll do the exact same thing to the tie-on eye. Remember, this is just a mock-up. It doesn't have to be strong. It just has to be in the right location and hold up enough to get a mold made out of it. Now with it repositioned a little bit, I can spin it and hopefully create a barb right here from some UV Cure epoxy. I'm just going to put a little bit on here to give it a coat, and then I can just spin it really slowly so it distributes nice and evenly. And when I feel it's pretty even, I'll come in with my UV flashlight and set it. That looks pretty good to me. And now what I want to do is just sort of make a bar by making some of this UV resin sort of sag down. And then I just stretch it out. And if my flashlight hadn't run out of batteries, I'd have that done. So we'll have to wait for that thing to charge back up. So while we wait for that to charge up, let's go ahead and unbox this vacuum chamber. Yeah, check it out. Comes with some nice measuring cups. So there's the pump head. What I was curious about is the seal. And it has a nice soft rubber seal. It might even be silicone. Feels really good. And the actual canister that forms the chamber in here, the walls are pretty thick and it's got some little stiffeners to keep it from flexing. While vacuum isn't as dangerous as compressed air, it can still damage a container if it's not stiff enough. And that just drops on. There's no need for latches or anything. And it gets powered up from this little transformer, which plugs into the head right there. So far, I haven't read any instructions. Maybe I should at least go over the how to get started section. So I really like the small details here. There's a nice soft rubber foot on this that won't let it move. Really nice. The vent is real simple. It's simply a silicone plug in the top of the chamber that will allow air in once you're done pulling the bubbles out of your material, whatever that material is. Once it's power up, you can see there's a little blue light there for the power. And this is just touch screen kind of stuff. Turns it on and immediately starts the power. There is a timer on this that you can set, and you set it depending on the viscosity of the material you're using and how cold it is. You have to experiment with whatever it is you're using. All right, so it's bringing the vacuum way down. I'm gonna see, can I stop this, like emergency stop? Yeah, nice. That's good, because sometimes something will spill. You just need to get it to stop. And let's go ahead and let the air out. Or air in, actually. Pretty cool. All right, so let's go ahead and try a little experiment. And we'll just take one of their cups with some water in it, put it in there, and let's see if it'll boil the water. And obviously it's not with heat. What happens is that the vacuum gets low enough where it reaches the internal vapor pressure of water, and that means once it's down at that pressure, it'll automatically become vapor or boil. You'll see bubbles. If it works, you'll see bubbles going where the water is becoming vapor. Let's see what happens. And I'm seeing the water just beginning to ripple, and we're at about negative 87 kilopascals. I am seeing some bubbles forming on the side of the cup, so it's almost boiling. Let's see if we let it go for a little longer. There it goes. It's starting to boil. That's really cool. So it boils water right at its maximum vacuum setting. All right, well, we know how to use it. All right, that is pretty cool. Let's get back to the project. With the UV light working, I can go back to making these barbs. It's easy work. I can trim the excess real easy and then set it really well with the light. This is going to be my mold box. I made it out of Lego blocks and then I filled it with clay. It's sulfur-free clay, so it plays pretty well with this silicone. And at this point, I'm ready to mark where I need to cut off those hooks because I can't have them sticking out through the box. So I'm going to put a little mark on them with the Dremel tool. This way I know just where to cut them with the wire cutter. And we'll set these in the clay in order of size, 1/2 ounce, 3/8, and 1/4 ounce. Now I can just hollow the clay out with a drill bit to get these things sunken in there about half their thickness. Half the thickness of the cylinder and half the thickness of the hook wire is set into the clay. And I'll take a little tool and just make sure that the clay is hard up against the edge of the disc. And we'll do that with all three. All right, that's got us pretty close. All right, since we're gonna be getting into mixing the silicone real soon, I changed into some old nasty clothes that I don't mind ruining because I got a feeling this is gonna be a little bit messy. Now, I'm not a big fan of smooth-on products. They're okay, they work fine. I just always find something that bothers me. And with this one, it's their mixing ratio. It's 100 to 3. They couldn't do 50 to 1? You couldn't reformulate this? Anyway, it just seems random as hell and gonna be a little bit fussy to measure out, especially part B, which is gonna be really small amounts, and I'll have to do it with an eyedropper. Now what I do like is that it's measured by weight, which is a lot more accurate and a lot easier to control. But I'm going to have to start off with the volume of the part A. And I've got a line marked on this nice little cup that I got with the vacuum chamber, marked right at 36 milliliters. Now the way I got the 36 milliliters was by taking the dimensions of my mold box, the depth, the width, and the length, and just multiplying them to get that internal volume. All right, so because this stuff has so much filler in it, you have to stir this thing pretty well. And you don't have to hurry because this is uncatalyzed right now. And I probably need to put some gloves on. I think that's right on the money. Working out of a bucket is just an absolute pain. I've got the mold box sitting right there and it's nicely leveled, more or less. Got my scale ready, my part B. I'm going to take an empty cup. I zeroed the scale with the cup on it. This way, when I put this cup on there, I get just the weight of the material. Now it's showing 70, almost 75, 74, and I know that's a little bit much. And I know that because the material sheet here says that the specific gravity of this stuff is 1.45. And if I multiply that times the volume I want, which is 36, I get 52. So that's really what I'm looking for. I'm going to pour a little of this out and hopefully I'll get it a little closer to 52. All right, I got it down to 57. I'm going to go with that. It's going to be a little extra volume for the case, but that's okay because I'm not sure how much I'm going to lose in the cup. All right, so now I just need to figure out how much of the part B to put in. And since I've got now 56.55 grams and it's a 100 to 3 mixing ratio, I'll just multiply that times 0.03 and I get 1.69. So I'm just going to put in 1.6. That should do it because there's just so much along the rim here that probably won't get mixed in. So I don't need to put in that much. So I'm going to zero. There's 1.63. That's good enough. It doesn't give you a whole lot of time for mixing. They say 40 minutes. But I think it's a lot faster from some of the stuff I saw online. It's a lot faster, especially in a warm room. And this is a warm room. And we still have to degas it, so can't take up my time too much. Got to get cranking. I knew this was going to be messy. Go ahead and degas this thing. Put this in the bottom on the lid. Brand new and I'm getting crap all over it already. Oh well. All right, starting to degas. And there it goes, it's rising in the cup. And it just sunk. So I'll let it go for another 30 seconds or so, and I'll get it out of there and we'll pour it in. And we'll just pour this in, hopefully it'll run. Oh yeah. Seems to be running pretty well. All right, I'm going to scoop the rest of this stuff out with the stirring stick. It's just a matter of waiting a few hours and pouring the other side. Well, I'm already in crappy clothes. Might as well get some other dirty work done. Looking pretty good. I'm going to do a little cleaning up around it so I can get all the little clay remnants off, and then we'll pour the second half. All right, we're doing the exact same volume as last time, so the same amount of part B, 1.6 grams. All right, I'm going to stir this up and then degas it. And I'll see you at the mold when I start pouring this thing. Right around now, I realized I forgot something. I forgot to coat it with Vaseline. No! Wow, what a screw up. I nearly blew it. I forgot to Vaseline the silicone before I poured the second half. I had it half poured. Well, I had a portion of it poured. I had to wipe it all out and made a mess, but I think I salvaged it. Let's mix another batch. But first, I'm gonna put some petroleum jelly over everything, including the jig heads, because now they have a very thin coat of silicone on them. And I'm afraid the next layer of silicone will stick to it. Oh, what a mess. I'm glad I caught it though, because I would have had to pour both sides again. All right, that should have it. Let's go again. All right, pouring the second half, take two. You know, I've probably made around 100 molds by now, and the only time I ever forget to put some kind of mold release, Vaseline or something, between layers is when I'm doing a tutorial. So I guess I'm gonna blame it on you guys. It's all your fault, otherwise I'm perfect. At least I get the volume right. No waste. I mean, other than this ridiculous amount of waste right here. All right, it's the next day, and I feel like I should say a few words. Have at least a moment of silence before I try opening this thing, because if it's stuck together, that's another whole day loss in this production. What a mess. There's these blocks just covered in this silicone. All right, here comes a moment of truth. Please open. Oh, it's starting to open. Oh, yes, we have success. Oh my God, I'm so happy. The next step is just to prep these guys to cast the lead in them. So I know I've carried you guys this far without telling you this, but this is a little bit of an experiment because this silicone is really meant for a little lower melting temperature of metals, things like pewter. So we're gonna be pushing the limits of this with lead. Hopefully it works perfectly. I'm counting on the fact that these are small pieces that we're casting in relatively a larger mass of silicone. All right, let me prep these guys and we'll start melting lead. And I'm gonna do that all three on both sides. And the idea is that that little bit of a funnel goes all the way to the full depth of the little cylinders we put in there. So it has a nice clear flow path, and hopefully that'll be easy enough to pour. All right, now we need to put some lead in our pot. And we got this ingot here. And I'm gonna stick this in my paint booth so I can turn on the evacuator. We'll turn it on and we'll see how long it takes to melt. In the meantime, we've got to load these guys in. All right, that looks pretty good. I'll put it in my little mold clamp, and I'm assuming I'm not going to need any vents in this thing, but we'll find out. All right, guys, I realized I didn't turn the camera on for the first pour. This stuff melted in about 8 minutes, and I had a little bit of an issue because apparently the pot stays cool enough that when you pour it, it sort of solidifies there at the spout, which that's not a good thing. But I think maybe if you leave the pot to get uniformly hot, maybe that'll do the trick. But let's see how this turned out. They may not be complete because of that cooling issue. Oh, it seems to be opening. You know what I remembered? I didn't put talc on this thing, so hopefully I didn't damage it. Oh, look at that. Wow, I'm surprised. I'm surprised it actually poured, well, I'm only seeing half of it. Oh, heck yes. Look at that. Let's cut off these sprues, melt them down. Let's make a bunch of these guys. The only thing I didn't notice until right now is that I didn't get my little barb. So I guess the lead wasn't quite hot enough to really run. So we'll get it on the next one, I'm pretty sure. I'm loving it. Look at that. Let's get a weight on these guys and see how close I came to my target weights. So the biggest one is 3/8 of an ounce, which we were shooting for 1/2 ounce. Missed that. The middle one is just over 1/4 ounce. And the smallest one is 6.6, which is just under 1/4 of an ounce. Let's go ahead and cast them with the lead a little hotter so we can be sure we get a full casting. Maybe the weight will change then. All right, not exactly the neatest pour ever. All right, let's see. See what it looks like. Not too bad. This one right here Didn't get a barb, but we'll see what we can do about that. Maybe I can clean the little barb section a little better. The other ones though look pretty good. All right, that looks pretty cool. Those are definitely usable. I'm gonna go ahead and cast a bunch more, put some eyes on them, and let's see how they work. This is the heaviest of the jig heads, and I put it on a 3.5 inch paddle tail swim bait. Now all the heads actually came out a lot closer to what the target weight was, just about a gram off on each one, just a little bit light, but I think I can still get them a little better with a better pouring technique. This swims really nice, and I really like the way the eye sort of wiggles back and forth, and that'll cause a little bit of flash underwater. Might attract more bites. Looks pretty cool in slow motion too. The second heaviest I put on a little sickle tail shad. Really like the way this looks. It looks so natural. From above, it has a very cool little action with the tail moving really fast. In slow-mo, you can see how the head almost stays perfectly vertical, just bobbing just a little bit. Really like this. This is a great bait out there on the flats. The smallest one is about a 2.5 inch little shad with a paddle tail. Doesn't have a whole lot of action. It needs a little bit of speed to really get that tail going. Right here I've got it going at about half speed. Thanks for watching this far into the video. If you want to try this yourself and you want to buy all this stuff, you can go to my Amazon store, look at the tools section, and I'll have everything in there. And if I can get a discount code from Resoners for that vacuum chamber, I'll put that in the description. And I'll put a link down there for the vacuum chamber and any other information I have on this stuff. And if you want to see more about making silicone molds, here's a playlist right here. Click on that, and I'll see you guys on the next video.